Hello, we are back. We are the group H. We have here in our subject data mining algorithms the topic association rules. So what is association rule? Association rule mining searches for relationships between items in a dataset. So it is commonly in the store, marami tayong mga makikitang mga iba't ibang item. So hinahanap dito sa nagsisearch siya ng relationship between dun sa mga item. It is aims to discovering associations between items in a transactional database. It finds combinations of items that occur typically together. So we have here the prediction task. Predictive data mining tasks come up with a model from the available dataset that is helpful in predicting unknown or future values of another dataset of interest. So si predictive data mining, ang task lang niya is to come up with a model na yung mga available data na makikita natin, example sa store, is nagiging kagamit-gamit para ma-predict yung mga future values o yung mga mas, yung interest ng mga bumibili, example kung sa store ang pinag-uusapan. So next slide, prediction task predicts the possible values of missing or future data. Prediction involves developing a model based on the available data, and this model is used in predicting future values of a new dataset of interest. For example, a model can predict the income of an employee based on education, experience, and other demographic factors like place of stay, gender, etc. So, ganon kaganda yung model na ganito is napipredict niya, kumbaga, mas nakakatulong siya dun sa isang association na mas maging kagamit-gamit pa yung kanilang mga data o parang mas maging yung system nila is maging kagamit-gamit pa in terms of predicting the example dito is employee. Kung ang employee ay nakabase sa education, experience, and demographic factors, mababase yung income ng isang empleyado. So the next example here is a medical practitioner trying to diagnose a disease based on medical test results of a patient can be considered as a predictive data mining. Also, prediction analysis is used in different areas, including medical diagnosis, fraud detection, etc. So, marami siyang gamit. Yung ginagamit natin na pag-predict, marami siyang gamit in terms of medical purposes. Ginagamit natin siya in business. So, iba-iba in fraud detection, etc. Diagnosis and medical diagnosis. So, iba-iba. So, marami siyang gamit.
Statistical Bayesian classification. Bayesian classification is based on Bayes' theorem. Bayesian classifiers are the statistical classifiers. Bayesian classifiers can predict class membership probabilities, such as the probability that a given tuple belongs to the particular class. Bayesian classification is a probabilistic approach to learn and inference based on a different view of what it means to learn from data, in which probability is used to represent uncertainty about the relationship being learned. The Bayes' theorem. It is named after Thomas Bayes. There are two types of probabilities. Posterior probability. Example is probability of H given X. And the next one is prior probability. The example is probability of H, where X is data tuple and H is some hypothesis, according to Bayes' theorem. Probability of H given X is equals to probability of X given H and probability of H and probability of X. The probability of H given X is equals to probability of X given H, probability of H given probability of X, where X and H are the events and probability of X is not equals to 0. The probability of H and X is conditional probability that describes the occurrence of event H is given that X is true. Also, the probability of X given H is a conditional probability also that describes the occurrence of event X is given that H is true. The probability of H and probability of X are the probabilities of observing h and x independently for each other. This is known as the marginal probability. The Bayesian interpretation. In the Bayesian interpretation, probability determines a degree of belief. Bayes' theorem connects the degree of belief in a hypothesis before and after accounting for evidence. For example, if we toss a coin, then we get either heads or tail, and the percent of occurrence either heads and tails is 50%. If the coin is flipped number of times and the outcome are observed, the degree of belief may rise, fall, or remain the same depending on the outcome. For proposition H and evidence X, the probability of H, the prior is the primary degree of belief in H, while probability of H given X, the posterior is the degree of belief having accounted for X. The quotient probability of X given H given probability of X represent the support X provide for H. Bayes' theorem can be derived from the conditional probability. Probability of H given X is equals to probability of H and X occurring given probability of X if probability of X is not equal to 0, and probability of X given H is equals to probability of H and X occurring given probability of H if probability of H is not equal to 0, where probability of H and X occurring is the joint probability of both H and X being true because probability of X given H is equals to probability of H given X.
Experiments with Weka prediction. Weka contains an implementation of the a priori algorithm for learning association rules. A priori works only with binary attributes, categorical data, nominal data, so if the dataset contains any numerical values, convert them into nominal first. A priori finds out all rules with minimum support and confidence threshold. Next is the step-by-step process on implementing prediction in Weka. First step is to prepare an Excel file dataset and name it as a priori.csv. Step 2 is open Weka Explorer and under Preprocess tab, choose a priori.csv file. Third step is the file now gets loaded in the Weka Explorer. Fourth step, remove the transaction field by checking the checkbox and clicking on remove as shown in the image below. Now, save the file as a priori test.arff. Fifth step is go to the association tab. The a priori rules can be mined from here. Sixth step, click on the choose to set the support and confidence parameters. The various parameters that can be set here are lower bound minimum support and upper bound mean support. This is the support level interval in which our algorithm will work. Delta is the increment in the support. In this case, 0.05 is the increment of support from 0.1 to 1. Metric type can be confidence, leaf, leverage, and conviction. This tells us how we rank the association rules. Generally, confidence is chosen. Num rules tells the number of association rules to be mined. By default, it is set as 10. Significance level depicts what is the significance of the confidence level. Seventh step, the text box next to choose button shows the a priori N10T0C 0.9, D 0.05, U 1.0, MO.1, S 1.0, C 1, which depicts the summarized rule set for the algorithm in the Setting tab. 8th step. Click on the Start button. The association rules are generated in the right panel. This panel consists of two sections. First is the algorithm dataset chosen to run. The second part shows the a priori information. The output. The association rules can be mined out using Weka Explorer with a priori algorithm. This algorithm can be applied to all types of datasets available in the Weka directory as well as other datasets made by the user. The support and confidence and other parameters can be set using the setting window of the algorithm. That's all and thank you.